Hello, everyone. It is a pleasure to be here and present you the demonstration of Spica Mobility Packet Core or the SMC Packet Core, the standalone 5G enterprise core developed by Spica Systems. Before we move ahead for the demonstration, this slide will describe the flow of our demonstration. UBORCA is the Kubernetes orchestrator with the help of which we will deploy the network functions. It is the recommended and suggested way of deployment of core, keeping in mind the scalability and various other advantages provided by the Kubernetes. As we can see, this will provide the interface for the user and will also control the clusters on which the core would be running. When the network functions are deployed through this orchestrator, the core will be spun up. Once the core is up and running, to simulate the UE and the G node B, we will introduce you to our test and measurement tool, Cygnus. The Cygnus will simulate the UE and the G node B. We will also try to bring to you our in-house developed CLI, which we call Kubelace, which can be used to upload or download your Docker images to or from your remote registry account. With this, let's move to the demonstration. This is the UBORCA platform. Let me first sign in. Once I have signed in, we can see the workloads which are there. We go to deployments and we see that already the core is deployed. AMF, AUSF, PCF, so it is deployed. But just for showing, this is how we can actually deploy. We have to specify the cluster, and that's how we can actually deploy any network function. Now, with this, that the core is running, we will now need to simulate the UE and the G node B, for which we will bring you to Cygnus. This is the Cygnus UI, and of course, the Cygnus is actually running. We have started it from the back end. Now, we need to create a G node B. So when we create the G node B, most of it is pre-filled information. However, we need to just provide the IP address, the NGAP address, the GTP address. Here, if we see, we can add AMF, the IP address of AMF. Most the PLMN and the others are actually pre-filled, we will hit the submit button. Once we have created the G node P, we will connect it to AMF. So we can see connection successful for GNB with AMF. Now, once it is done, we will move to the UE groups and will create a UE group. We can say the number of identifier 1. We will, for this demonstration, we will choose 2 as the number of UEs. And the rest are pre-filled. We will submit. Now we have to allocate a GNB to the UE. And we will allocate the UEs to the GNB which we just created. Now, after this, we can actually carry out the 3GPP specified operations like registration, PDU session establishment, deregistration, and PDU session release. We will try and register. The dashboard shows the UE registration procedure, so it's 100% success. Now, we will also establish the PDU session. Again, we go to the dashboard. We can see that PDU session establishment is 100% success. In the same way, we can go for PDU session release. Again, in the dashboard, we can see. Now we will deregister. Hence, we are seeing how the UEs are registered to the core, and when the PDU session is established, then the communication within the network functions is perfectly fine. For more detailed presentation, please contact us. Thank you.